Question 14. A monochromatic light wave is incident perpendicular to a diffraction grating. A third-order maximum occurs at an angle of 40 degrees relative to the normal of the grating. The diffraction grating has 4,500 lines per centimeter. What is the wavelength of the incident light? This problem tests our understanding of diffraction gratings. Let us begin by recalling what we already know. We know that the diffraction grating equation relates the order of the maximum, the wavelength, and the grating spacing. For any diffraction maximum, the formula is d sine theta equals m lambda. We also know that the grating spacing d is the reciprocal of the number of lines per unit length. So if a grating has n lines per meter, d equals 1 divided by n. We also know that higher order maxima occur at larger angles, which means the third order maximum will appear at a bigger angle than the first or second. Now let us calculate step by step. The grating has 4,500 lines per centimeter. First, we convert this to lines per meter. 4,500 times 100 equals 450,000 lines per meter. Next, the spacing between the slits is d equals 1 divided by n. Substituting the value, d equals 1 divided by 450,000, which is approximately 2.2222 times 10 to the minus 6 meters. The diffraction equation is d sine theta equals m lambda. We can rearrange this to solve for the wavelength. Lambda equals d sine theta divided by m, substituting the known values. d equals 2.2222 times 10 to the minus 6 meters, theta equals 40 degrees, and m equals 3. This gives lambda equals 2.2222 times 10 to the minus 6, multiplied by sin of 40 degrees, divided by 3. Calculating this, lambda is approximately 4.7613 times 10 to the minus 7 meters. Rounding to two significant figures, lambda is approximately 4.8 times 10 to the minus 7 meters. This is our final answer. What did we do? We first changed the given line density into lines per meter to keep our work in standard units. Next, we determined the slit spacing d as the reciprocal of the line density. We then substituted the slit spacing d, m equals 3 for the third order maximum, and the corresponding angle theta equals 40 degrees into the grating equation to determine the wavelength. There are few misconceptions to take note of. A common mistake is using the given line density, like 4,500 lines per centimeter, directly as the grating spacing d. The correct spacing is d equals 1 divided by n, and n must first be converted to lines per meter before taking the reciprocal. Here is a summary of the key points. The grating equation d sine theta equals m lambda links the slit spacing d, the diffraction order m, and the angle theta of the maxima. Always convert the line density to SI units first before calculating d. A grating with n lines per centimeter must first be converted to lines per meter before using d equals 1 over n to find the slit spacing.